So here's the problem. All right, we've got the Echoplex unit, and I do like the way that it sounds in terms of its warble and its the quality of the repeat. All of that stuff is right on target for the project. And I've got this pedal fire here. It's not the small box 3, but just for demonstration purposes. The problem I'm having, which I discussed in the earlier video, is the wet to dry ratio. In that, this unit, it's hard for me with my setup the way it is to get, let's say, the ratio low enough. It's too wet. Even run very low, it's too wet. I'm not really getting what I'm looking for. I'd like to be able to turn it up a little bit and have some ability to dial in the amount of slap back, how strong that slap is, a little bit better. The other issue is with the small box 3, since it's basically a plexi level of gain, which is what I'm looking for. I do want to boost the front end of the thing. Now the problem is with this unit, if I run a boost in front of it, like I want to run an EP3 or something along those lines, a jfet sort of boost into the amplifier to boost it up to the levels I want to get that kind of sound. If I run it before the Echoplex unit, or even after the Echoplex unit, it only exacerbates the problem of the wet to dry ratio, leaning too far towards wet. So what I decided to do, and some of this, the inspiration for it came from a friend of mine, Bill Webb, who's an amplifier tech extraordinaire, as I mentioned before, and EJ's tech. And I saw in a rig rundown where EJ was describing his setup using, he always used a real, Echoplex EP3, one of the Maestro units or whatever. But he's switched over to the pedal, but he felt there was an issue as well with that, I guess. I'm not sure exactly if it was the same issue or not, but what Bill did was he built him a box or some sort of a circuit that surrounded the Echoplex pedal, which made it closer to the original units and allowed a little bit more boost. So I'm thinking, yeah, that may be a good idea. So what I did was I pulled up the Echoplex, the original schematic of the tape unit off the internet. And I'll just show you sort of on paper what I'm talking about here. Now the way that the original Echoplex worked was you had, I'm going to use the big marker, you had your incoming signal, all right? So this is just your normal waveform, right? That would go into the unit, okay? Now when you're inside the unit, the first thing it saw was the jfet stage, right? There was a jfet sort of boost stage, which was that TIS 58 transistor, right? So that was the first sort of thing it saw. From there, it may be a little bit more complicated than this, but I want to simplify it for the purposes of understanding better. What happened was basically this signal then went to a potentiometer, right? You had basically the center lug of a pot that was grounded, a left and a right, okay? So basically this crossed over to this potentiometer, as well as there was another signal that it went to a pot, but let's just say it went into the tape heads, right? There's an A in there, you dyslexic bastard. Right, so from the tape heads, it went to the other side. So as you can see, it's run in parallel, right? So that's kind of what I want to do. So what I'm thinking about doing, all right, is let me get this piece of paper out of there. What I'm thinking about doing is taking apart the Echoplex pedal, right, and rehousing it in this guy. And adding circuitry that will allow this sort of a signal flow, right? So what I'm essentially going to be doing is, let's say, let's take this box here, all right? And we're going to build this thing, and you guys are going to kind of see it go through its stages. And if it works out, it works out. If it doesn't, well, hey, I'm an idiot. All right. So basically, what I envision having here is rehousing this unit, right? So we're going to take the unit, all of the components out of this Echoplex, and we're going to put it in the other box, right? So what we're going to have is something like this. Let me just draw this as the secondary, just to give you the concept here, right? So we're going to have these 3 potentiometers, right? And the stomp's still going to be there. And then we have its input and its output, okay? And then we're going to add an output here and an input here. All right, so this will be on the main box. So our guitar signal will enter here, okay? Let me use the big marker again. So our guitar signal will enter here, all right, into this unit. And this will be our exit, right, out to the amp. Okay, and in. All right, so what I want to put in here basically is a jfet preamp, but it's going to be split, right? So we're going to come into, I don't want to boost this. So this already sort of has an initial stage. So what I'm going to do is I'm going to split this signal here. One is going to go into the unit, the Echoplex unit as it sits. And then we're also going to we're going to put in a jfet boost, right? Inside the box, so to speak, block diagrammed out, which it'll also enter. So the input signal will just be wide off, one going into the Echoplex unit, all right, and the other one going to the jfet booster. We're going to put another potentiometer up here, right, which will be sort of our blend pot. So we'll have the output of the jfet going there, as well as the output of the echo unit, right? So this will be another potentiometer on the box itself up here someplace. So we'll have an input, an output, and a sort of a blend, another blend potentiometer right here, and then out to the amp. So we'll have the ability to sort of get over the signal, the delayed signal as well. I mean, if this had a dry kill in it, that would even be better. But it just has a tail switch, so we're not going to be able to do that. All right, so that's the general plan, that we're going to be running a parallel boost along with this that will recombine the echo signal with the boosted signal together and then enter the amplifier. All right, so I think that's where we're gonna head. So let's start building. Okay, so let's get down to the fun part now. Everybody wants to see, right, is taking apart and destroying this pedal. That's the first step. We got to take out the guts out of this guy. So let's start doing that. So the first thing we're going to want to do is pull off the knobs. Okay, got the knobs off. Put them in the bag. Reserve all our parts in this little bag so we don't lose them. Next, we'll take off the back cover and see what we got in there. Remove the 4 screws. Almost lost one there. I like to use my stomach as a little, my belly button as a little point to twirl my screwdriver in. Sometimes makes things go quick. All right, so we got the back cover off. Let's take our back cover screws and reserve them again in the baggie. Let's take a look and see what we got. Well, usually these things are mounted by the jacks and the pots. They don't really build things the way they used to. All right, so it looks like we got 4 screws for this, some pots and all of that stuff. All right, so let's take off these screws. Take out these screws rather. And we'll see what we got in there. Taking apart the MXR Dunlop Echoplex. There we go. You can see right there, there's that little switch for the tails feature that they referred to in the manual. So if anybody's looking for that, there it is. Okay, let's get these 4 out of here. All right, let's reserve these back into the baggie. And there will be obviously more than just 4 screws holding this thing together. Alright, next I think what we're going to do is we'll take off the jacks. And that should be one of these guys. This guy right here. Alright. And we don't have to put these in the bag. We can kind of reinsert them into the unit in a minute. We also have the, what is that, the tap tempo switch. Let's see. One bigger. Yep. Alright, let's take off that switch. Alright. Now we should take off these top nuts. This should be a 1/2 inch. Yep. So we can take off the stomp. These are usually 10 millimeter, and it is. So we're moving the nuts off the potentiometers. Very dramatic. Last one. Alright, so push that through there. I'm guessing probably is going to come out now. Let's see, we may need something to grab a hold of to lift it out of here. There we go. Now be gentle with this kind of stuff because you don't want it to break. Alright, so we got the unit out. Looks like it's actually two boards. This was off the jack here. So I'm going to screw all this stuff back on our boards, or on our board here, so I don't lose it. So that can go there. And the little input and output jack, washer, and nut can go back in their places so we don't lose those. Right? I'm probably not going to use them anyway. We may remove these jacks, we may not remove these jacks. We're going to have to evaluate how much work we can do to these boards without destroying them. Modern circuitry is a lot more delicate than the old stuff was. It doesn't take to being reworked very well. A lot of times just trying to remove one component with surface mount components, you can destroy a board pretty quickly and then render your little toy useless. So we're going to have to do a very careful evaluation as to what we're going to be able to do and not do here. But now, in any case, we've got this board out. Let's get out magnifying glass and look at everything here. A lot of surface mount. I think I'm going to try to zoom in for you guys too so you can see. I mean, it's not what you want to be working on. Alright, so we'll put that aside. Now we've got a second board here with the potentiometers and another IC on there. A Molex connector to connect the two boards together. Alright, so 2 screws looks like. So we're going to pull these two. That's one. Probably a good idea with this, considering what I'm seeing in here, to have some anti-static protection. It does look like there's some programmed devices in here for sure, which don't like static, but we'll take our risks. So now we got our second board there. It's got some potentiometers and LED. Little IC there, Molex connector type thing. So I think we'll just put these together just to keep them nice. Alright. Now this is, yeah, I don't think we're going to need the tap tempo, so maybe we should just, right now, remove this. There we go. Put that aside. So that'll be our board. Now we can use this plate. So let's remove that. with these screws, and hopefully it's not glued down. So then we're gonna have to heat the thing up. I doubt it's glued. If anything, it may have a little hot glue. Peel it off with some tape or something. And I feel it slipping already. I think it's just gonna come right off. That's cool, because we can use that to keep the kind of echo look. Yeah, it's only held with the bezel for the LED, so we could just crimp that and push it through. There we go. So there's our box, our original MXR box, right? The plate, control plate, and such. So you know what we can do? Let's take out our back screws and put this guy back together again. That would be the simplest thing to do, I think. 1, 2, 3. There should be one more here somewhere. 4. Alright, and put all the rest of the little screwballs. You know what, we can probably put them all in there. I don't think we're going to need them. Alright, so let's... Easiest way not to lose them is to keep them in the unit, right? So let's put all our screws back in the unit. That was good. I think these are all the same thread. I shouldn't be having a problem getting them back in. No, that's fine. Okay. I always like to load the screw onto the driver. Makes it so much easier for putting things in, instead of kind of putting it with your hand and then trying to stick your Phillips head in the screw itself. It just seems, well, we got to put the cover on, right, dummy? No, I don't. They're all the same. What's wrong with me today? It is Sunday. So, I have that excuse. Alright, so got 2 more of these little guys to put in. And then we could just put this box aside in case our experiment proves to be fruitless. We can always put the Echoplex pedal back together again. But I think we're going to have success with this. Mainly, I mean, we could do a splitter box and keep the unit as is and run the jfet sort of parallel system through a secondary splitter box like a loop, but we're kind of running out of room. And there isn't a whole lot of circuitry in a jfet boost, right? What do you got in there? You got, you know, source, drain, gate, a few resistors for that, capacitor, 1 potentiometer. You know, using a whole box for that just seems kind of a waste of space. So I think if we can combine all of our needed parts into one box that's only marginally bigger than this, we're going to be in good shape. So we'll have this box here, and we'll mount our pedal, mount our little control panel on there to keep the look stock, so you know what it is still, right? And then we'll put all of our circuitry in there. So the next phase is going to be basically drilling out this box to accept this circuit right here. So we're going to need to drill the holes for the stomp switch, for the 3 potentiometers, and that's really about it. And the 4 screws to hold on the control plate. Now the question is, what to use as a reference for drilling? Well, probably this. So let's just say, doing this live, figuring out on the fly. So maybe we'll be doing a lot of forward tracking and back tracking and side tracking. I even counted a flash sideways for those Funny Farm fans. Alright, once again we got the box open. So, yeah, I think that's how we'll do it. Maybe double stick tape this guy down. Line it up nice and square, let's say, so everything looks nice. We'll take our little machine square here and line up our box nice and square. Double stick tape this down, and then use the actual case as a drill guide. Okay, so let me get the tape and start taping. So I'm going to pause right here, and we'll be right back with some double stick tape. We're back. We've got some stuff to do the work with. I've got my double stick tape, brought up some drilled bits. This tape is basically golf grip tape. It's sort of thick double stick sort of stuff that I really like to use, and I just order it or get it from the local golf supply place, and it's useful for amp building and guitar building and everything else. So good stuff to have. So we got the tape, we got our drill bits, and a few other things. Then I did some thinking about how to get this all to line up, and so that we have a nice looking unit. I've got an idea of a trick to use to get everything in the place that I want with as little problem as possible. But the first thing I would suggest doing is getting your drill bits the sizes that you want before you tape everything down, right? Because otherwise you can't tell what size you're looking for. So first thing we're going to do is just do that, right? So just offhand, I'm pretty sure this has got to be 1/4 inch, all these guys having built stuff for so long. All right, so those are the quarters. This little guy here, I'm going to say it's, what, an 1/8 inch? Do I have an 1/8 inch in here? I always break them. Should be an 1/8 inch in the other set. Yeah, it may even be one bigger. Yeah, here we go. All right, so we got a 9/64 bit there. Okay, so we'll take that out. This one here looks a little bit big. No, it's a little smaller. Let's go down. Make sure we got the right one. All right, so it looks like for that one we're using, what do we got there? 1/4 inch, 9/32. All right. And then for the large hole, that's got to be a 1/2 inch, right? Let's grab that. It has the little notch in there getting in the way. But yeah, that's our bit for that. All right, so we have the bits that we want to use so that we don't have to guess anymore. Now the order and style and technique for drilling all this stuff out. All right, so my guess is this. All of these smaller bits are going to be able to chase through these other holes pretty easily without wandering around, right? Even though they have, on the tip, you can sort of see here, there's a little bit of a brad point there. So if you're a little left or a little right, it may tend to push the unit out of the way, especially on a big bit, right? Because by the time you get to the widest part of the bit, that would guide itself on the this case here. That brad point is already a 1/4 inch through. It's already through. So if it's in the wrong place, it's just going to shove this box that's taped down right out of the way. So that's not going to work. That's not going to be, you're not going to be able to do that by eye, really, and line it all up with all your other holes and make it nice. So the solution, in my opinion, is this. This will be the keystone hole, so to speak. So what we'll do is we'll drill this hole first, all right? And we'll do that very simply. We'll mark with some green tape here and get out our tape again that we always like to use. All right, take some tape. I'm the only guy cutting tape with scissors, right? Masking tape with scissors. Gotta be crazy. Put the piece of tape down in the area where the hole generally is. All right. And then we can sort of line up where we want our unit to be, left to right, up to down. Right? You can even use the square if you want, just to make sure you got it sort of where you want it. Okay. You can scoot it over actually, because we're going to be soldering to that jack. We don't really need much room on that side. I'd say right about there is where we want the unit, left to right, now up to down, top to bottom. Get that in the middle, right? Right there. That's where we want the unit positioned. Now what I'm going to do is I'm going to take my pen and I'm going to find the center of the circle, right? Now the most I'm going to be off on that is like maybe a millimeter, right? By eye, just a tiny bit. And we can square it up because it's one single hole. So my plan basically is to now just drill this hole out to 1/2 inch, right? Then tape the box over, use another switch, right? To come up through the box and through this original hole, and then tighten this down so that that switch is known, it's locked in position, it's helping press this case against the other case when we're using it as a drill guide, and then we'll drill out the other, 5 holes, and then we'll be done, and everything will be exactly where we want it, and then we can mount our nice little control plate on there, and everything should line up fine, and we'll be good to go on to the next step, which will be getting into the internal components. So what I'm going to do is I'm going to first start off by, drilling pilot holes, right? We're not going to start with a big bit right away because that's hard to center. Aim small, miss small, right? So we're going to use our little 1/16 inch bit. We're going to get it right on that circle, right on that dot. And this is that's our keystone hole, right? Everything about the position of this is going to follow from that. Okay, so we got that in, then we'll just ream it out, let's say with our 1/4 inch, or rather, excuse me, 1/8 inch. Now we have something for the big bit to follow into, right? Let's take our chips out of the way. Our big bit can now lock in on that, and we can go ahead and drill through. Now, I'm not going to use the unibits, nor am I going to use a hand drill. I guess you could try that. I'm not in the mood for doing that. I'm going to go and go downstairs and get on the drill press and just drill out this hole. And then we'll continue from there. So I'll be right back after drilling this hole out on the press. All right, so we're down there and we just use the big sucker to drill it out. I'm going to put the bit away. And we can continue on, peel off our tape. Right, and there's our hole. And that we're going to consider the keystone hole. Everything will follow from that. All right, so I'll give you a general idea of sort of what's going on here. Right, so we're going to take all this stuff off. Right, and then we can place this piece through. Put the washer on, sure, why not? Place it through, and then line it up like so, and then we can put our screw on there. Or rather a nut, right? Then we can just square it up with the square, right? So it rotates. So then we're perfectly square. We can take our little guy here, And now we have it basically fixed there, right? So it's not going to move around. It's not going to mess anything up. But we're going to want to put some double stick tape to avoid it moving sideways and kind of shaking. So let's go ahead and do that. But I wanted to show you the general idea that we were going for to kind of keep everything, give you the best chance for having, you know, all the holes line up where you need them. Okay. All right, so we're gonna take a little bit of tape, scissor, like so. I'm gonna affix the tape to this unit itself, to the box itself, as you know, that's kind of where it is, right? Take that off, and we can once again place our switch in there. Fire it on, right? Now, you can just put this washer, nut, whatever you want to call it. I always call things wrong stuff, especially now that I'm getting more mature. Alright, so now we're going to square this box up, right? Make sure it's nice and square. And it is. And we can just press down the tape a little bit. Grab our socket. And we can even get our wrench here just to help, you know, make sure it's tightened down but good. All right. There we go. Now we've got something here that ain't going anywhere, right? So now we can basically look at everything. Looks square to me. All right, so now what we can do is we could go ahead and remount or drill out our next 4 holes on the drill press. I'd recommend using a drill press, as you know, you'll be able to get everything perpendicular rather, and keep the same error, and everything will work out really well. So I'm going to go ahead and drill out the rest of these holes, and I'll be right back. Back from drilling, we got our bits to put away. Everything went smooth. No issues. I think we're going to have a good lineup of everything. You can see there's our holes. Nothing moved around, so everything should be good to go. So let's go ahead and double check there's nothing that we need to do. Actually, you know what? We could probably drill those out. Those are actually little guide holes for the potentiometers, as they have little things on them that help lock them in place. All right. That's good. Take out our chips. Maybe do a little bit of vacuuming here and get this stuff up. All right, so let's take it off. Remove our bolt. that was there to secure everything. Put it all back together again. Save that for later. Then we could just basically pull this off. All right. And there is our drilled out box, ready to accept the parts from the original unit. So let's do a quick test fit. We could start by, we might have to open these up depending upon, no, that looks good. Here we go. Oh yeah. How cool is that, right? That's gonna look pretty good. Has a little pedal there. Let's continue to test our fit. We can carefully remove our, let's call it the pot board. How good is that? Then we can see exactly where we're going to put all of our little doohickeys and jammies, jacks and such. We might put a breakout box in here too for power as well, because we're going to run, it's going to be 2 voltages in running this, right? We need a 9-volt DC to run the actual MXR Echoplex unit, but our particular boost, we're going to be running off of 18 volts. Now, the original TIS 58, you'd be running higher than that at some 25 volts or something like that. But what we're going to use, let's see if we can get this lined up correctly. There we go. Right? How good is that? Right? Let's pull it back off again. We had the nut still there. We're going to be using one of these, right? The new in bag NTE 452. Now, some of you guys may recognize that particular jfet as being the jfet that the guy that rhymes with humble used for his FET input on his famous amplifiers. Now, I'm not going to copy his stuff ever, right? Through a mutual friend, I had learned some time ago that he actually likes us, Greg and I at Three Monkeys and Brad, because we never really kind of took any ideas from him, so to speak. We kind of just ran with our own thing when there was a lot of a lot of other stuff going on, so to speak. So I don't want to steal from the poor guy. All right, so that looks pretty good right there. Right? Cool. Got plenty of room to put our circuit in right here. A couple of jacks. So we'll have, let's say, maybe put 2. I've actually got room under here too. Could probably put 2 DC jacks here. Say like 18 volt in, 18 volt out. 9 volt in. Have our output, our box output. Our box input and our potentiometer should all fit pretty nicely. Should all fit really nicely. All right, so the next thing I think we need to do in terms of machining, there's one last thing to do really, and that would be these four little guys right here, right? Just making sure this doesn't move around at all. Right, that looks pretty good. We're going to want to drill for the machine screws that kind of hold the plate down on all 4 corners. Now I'm going to take a look at the machine screws and see what they are, to see what kind of drill I'm going to need to use. and whether I should go and get a tap to tap these as well. I want to see if they're self-tapping. I don't see any cut in them, so those are not self-tapping. So we'll put them back in the bag. Oh, let's see. They may, I mean, this aluminum's so soft. In a battle with steel screws, aluminum generally loses. So let's just figure out what we're going to use for our drill here. We want it to be just undersized to be able to fit through here. So this one's too big. So we're going to be using a 5/64 bit. I think that'll work good. A 5/64 bit. Now let's see, how would we want to do this? Would we want to start the drill? That looks pretty good. So I think what we'll do is we'll just kiss it with an 1/8 inch on the press on all 4 corners, which will leave us a little dimple, and then we can chase that out with the what did I say that was again, the 5/64 bit, and then we can just either get a self-tapping screw of the same thread, or we'll just try our luck with a little bit of machine oil and just carefully use the screw as the tap itself. All right, so I'm going to go quickly and machine out those on the drill press, and I'll be right back. All right, so back from doing that quick little procedure. See, we got our little holes. That idea worked out really well, just kind of kissing it with the bit that matched the diameter of the hole in the plate, in the control plate, to create a little dimple, a little ditch, in which the appropriate smaller bit will find the bottom center of it pretty much perfect. So now we have, I think, all of the holes that we need. We're good to go. So let's try doing our, put all our parts in there. Try doing this right here. Let me take a little bit of, well, let's not use oil, we'll use a little wax. Any sort of lubricant will work good. Obviously wax is a little bit of a lipid, I believe. So I just don't want to spill oil all over the place. So I'm just going to use the actual screw as the tool. And I'm just going to start by applying pressure and then working it both ways, a little bit forward, a little bit backward. Seems to be working just fine. I'm actually putting some threads in there. I'm going to put a little bit more wax on the end of the screw so I don't snap the head off. Heat everything up too much. A little bit of cooling effect of the reduced friction. Back it out again. Clear some of the chips out of there. Go back at it. Go in reverse to find the thread, right? And then go forward, get in it. So that way we don't thread it twice. I mean, look at that. There we go. Nice and flush. Perfecto. So I would recommend, if you do it this way, in any case, and in any situation where you're kind of, let's say, breaking the rules of proper machine shop procedure of not using a proper tap or die or whatever it is you're going to be using for threading or for what have you, maybe just use the screw once so that you don't continuously weaken the same screw over and over again. If you break one of these, you're going to hate life. Alright, so I'm going to back it out a little bit again. clear out some of the chips. Go ahead and put it back on there again. A little more wax on our thread. Using good downward pressure to kind of force the screw head into the hole. This particular one, well, that's another weird thing about screws, is that sometimes you'll get lucky, which I may have already done, that a particular screw may have a burr on it. It may have been nicked by a machine already that's helping it cut threads, right? It's helping it cut into the aluminum. So we'll try another screw here. I think we're getting somewhere with this one. Oh yeah, we're definitely getting somewhere now. Hopefully it's not hell. Just because you're getting somewhere doesn't mean you want to go there. I think we're good there. Grab another screw. And I could put a little bit of a nick, grind a little slot along the length of the screw head to help do this. I don't know whether that would be a great idea either. I think this is just a number 4. I think I have some stainless number 4s here that might help with this too. Let's check to see what these are. Yeah, it's a number 4. So we can use one of these guys too to help. Just in case those happen to be less than stainless. I mean, it wouldn't exactly be very hard to go and get a 4x40 tap at the home center and just do this correctly, which is what I may end up doing if I do this again. Although this is working, it's obviously not the best idea. Okay. Where's our last screw? All right. All right. Now, so let's see. We'll put our knobs on just to get a look at what this thing's going to look like. Get that going. All right. And I do believe somewhere right here I should have some more screws that look kind of like that, or rather knobs that look kind of like the MXR knob, although it's not perfect. I got these from CE distribution. They're just the miniature chicken head knob, and that can go there. right? So this will be our blend, right? For mixing dry to our boosted signal. We may have a couple of ideas of how to optimize that sort of situation right there. We may not end up going with the exact blend pot. We may just use a resistive divider and use this as our a static resistive divider of a pre-chosen ratio, which is just basically two resistors that are joined. One will be the echo signal. The other one will be the boost jfet only signal, and that we can control the ratio by just the level control of the jfet circuit. Or we could even do two, right? We could do a combine, right? A mix knob as well as a boost knob, right? So we can have both. That may be what we end up doing. So we would have, let's say, two potentiometers. We're going to need two jacks, an input jack and an output jack. Could probably put them here, in and out. DC 9 in, DC 18 in, and maybe put a DC 18 out if there's room, so we don't waste valuable ports. Being that this will be 18 volts on this NTE. I mean, we're talking about, good Lord, there's nothing, Has somewhat of the data on the front of it, but what are we going to see on this thing? Not much, a few milliamps, that's about it. So, compared to a Strymon pedal that's using 300, 400, 500 milliamp, this is basically non-existent. So to waste an entire port to run 5 milliamps is ridiculous. I'd rather have a parallel or series parallel rather extension, so I can power the next pedal over that's 18 volts and not waste a spot on the port. So anyway, I think this is a good place to stop for today. I'm going to start designing the circuit a little bit closer and laying everything out. But we'll keep you in the loop as we go through the whole project start to finish, and then put it on the board and see how it all sounds. All right, so thanks for watching, and we'll speak to you later.